Hello, today's lesson is about factoring polynomials, which we can find in section 6-4 of our book. And we have 4 objectives today that we want to learn in this lesson. First, we want to use the factor theorem to determine factors of a polynomial. Second, we want to factor a difference of squares. Third, we want to factor common monomials and then redistribute them. And last, we want to factor the sum and difference of 2 cubes. Alright, let's get started. First thing I need to do is I need to remind you of something you learned back in 3rd and 4th grade. Any number divided by a factor will have a remainder of 0. Well, the same is true for polynomials. Alright, let's see what I mean. If we plug in any number a, and I would use synthetic division to do that, if I get a result of 0, then x minus a is a factor of that polynomial I was dividing into. And here's the factor theorem to prove it. For any polynomial p of x, x minus a is a factor of p of x if and only if p of a equals 0. Alright, well, let's look at an example to make sense of what they just said. P of x equals x squared minus 1. If x minus 1 is a factor of it, then the p of 1 should give me a result of 0. So if I plug in 1, I get 1 squared, which is 1, minus 1 is 0. 1 gave me a 0, so x minus 1 is a factor of x squared minus 1. Alright, let's look at an example in detail. Alright, we're going to determine whether x plus 1 is a factor of x squared minus 3x plus 1. Well, if I'm using x plus 1, my a is a negative 1. We use synthetic substitution. Bring the 1 down. 1 times negative 1 is negative 1. Add these terms. Negative 4 times negative 1 is a positive 4. Add these terms, I get a 5. So if I plug in negative 1, I get 5 for my result. The p of negative 1 is 5, not 0. So x plus 1 is not a factor of p of x equals x squared minus 3x plus 1. Alright, now that is an example that did not work. Alright, this one is an example of one that will work, but I want you to try this at home. Make sure you get it where it does work, and if you can't, then bring it to me tomorrow and we can work through it if we need to. Alright, so pause it now and write it down, and I'm going to go on to the next objective. Alright. You're already familiar with many methods for factoring quadratic expressions. Well, you can use these methods oftentimes to factor polynomials of higher degrees. So I would suggest that you might go back and review section 5-3 just to refresh your memory. Alright, now, one of the things I want you to refresh most definitely is a difference of squares. X squared minus a squared, for example, would be factored into x minus a times x plus a, and this is actually our second objective because you're going to see this again and again in our homework and in problems when you factor. Alright, now let's go on to objective number 3. Objective number 3 is all about factoring by grouping. Alright, let me show you what I'm talking about. When you get a polynomial term, one of the ways that you can factor is to group the terms in ways that they have a common factor. I look at x cubed and x squared. Both of them have the same coefficient, a 1, and they're opposite signs. When I look at the negative 25x and the positive 25, same coefficients, opposite signs. That's a good way to factor. Alright, now I'm going to factor out a common monomial from each group. I pull an x squared out of the first one, and I'm left with x squared times x minus 1. a negative 25 comes out, and you've got a negative 25 times x minus 1. Right? And all this is the distributive property. We're just going in a different direction than we normally do. Normally we're combining. This time we're factoring out. But since both of these terms in red are being multiplied by x minus 1, I can rewrite it like this. X minus 1 times x squared minus 25. That is a difference of squares. We factor it. We have x minus 1 times x minus 5 times x plus 5. And we're done. Alright. This slide right here, this is the problem I want you to try. Just like the one we just did. Pause it, write it down. You should be able to factor it. Take it down as far as you can. And when you're done, you're done. If you have any questions, bring it to me tomorrow, and we'll talk about it. Now let's go on to our last objective. Just like there's a special rule for factoring the difference of two squares, there are special rules for factoring the sum or difference of two cubes. Here they are. Sum of two cubes, a cubed plus b cubed, in a generic case, would be a plus b. Notice that the small parentheses kept the sign, and in the bigger parentheses you've got a squared minus ab plus b squared. The way I remember this is it's almost a perfect square, except normally you would have a 2ab here, but this time there's no 2, it's just a single ab. The same thing goes for the difference of two cubes. A cubed minus b cubed. Again, the small parentheses kept the sign, and the big parentheses changed signs in the middle, and it's almost a perfect square, except there's no 2 here in front of the AB. Alright, so that is my way of remembering it. Now let's look at an example. Alright, I've got 4x to the 4th plus 108x. Now the 4 and the 108, neither one are cubes. And then I have an x to the 4th and an x. Neither one of those are cubes. But one thing I noticed, I can factor a 4 and an x out of both those expressions. So I get a 4x times x cubed plus 27. Now the x cubed plus 27, I recognize as a sum of cubes. So I'm just going to rewrite it, changing the 27 into 3 cubed. And now I'm going to factor it using the rule we just learned. So I got 4x times x plus 3, so we kept the sign. X squared minus x times 3 plus 3 squared. So I got 4x times x plus 3 times x squared minus 3x plus 9. Alright, and that's all we can do. Alright, now here's the one I want you to try. Now, just a little bit of a hint. 125 and 8 are both perfect cubes. So you should be able to factor just the way it is. So try that. I've got one more small thing I want to show you, and then we're done. Alright, the volume of a plastic storage box is modeled by this function here. Identify the values of x for which the volume equals 0, then use the graph to factor the v of x. Alright, well, here's the graph. Now, one thing you can tell from any graph, whenever the line crosses the x-axis, that is going to be a point where you have a factor that's going to give you a value of 0. So here we're looking at a negative 5, a negative 2, and a positive 1. So if we plug those numbers in to this equation, we should get a 0 for an answer. In this case, you would have a 0 for your volume. Alright, you can check that using synthetic division, which I'm just running through real quick. It worked, and then you have your factors. Factor this last one as you can, and you got it.